Hello and welcome back to the lab. On the bench today, we have the latest little accessory addition to my lab, the HP 350D Attenuator Set. Um, I have plenty of 50 ohm attenuators, but this is a 600 ohm attenuator and I didn't have one of those. So I went on the auction site and they had one up for auction. They were allowing bids on it, but the buy it now price was so cheap that I just paid the buy it now price, and here it is. So this is the HP 350D attenuator set. It's a 600 ohm attenuator, 600 ohm input impedance and 600 ohm output impedance. And what that means is it's basically an audio attenuator. Um, Many instruments from this era used 600 ohms as their input and output impedance because they were basically audio equipment or telecom equipment, and 50 ohms was more reserved mostly for uh, RF equipment. So they call it an audio attenuator set. It actually goes from DC to one megahertz. So that's the other interesting thing about this instrument is it actually works at DC. And in fact, the way it's actually calibrated and tested is using a DC power supply on the input and a high precision digital voltmeter measuring DC at its output. As you step through the ranges, you record the readings and make sure they're within the accepted tolerance. Um, the tolerance on this instrument, the specifications are plus or minus 1/8 of a dB. Um, on every step, um, below 100 kilohertz. Above 100 kilohertz, it's specified to be plus or minus a quarter of a dB from its nominal dB setting. It has 10 dB per step attenuator at the bottom. It goes from 0 to 100 dB of attenuation, and a 1 dB per step attenuator at the top goes from 0 to 10 dB. So it's a total of 110 dB of possible attenuation with this attenuator set. Um, when I got this one, it was in very good condition. Um, on the outside was clean. I didn't even have to clean it. It was missing the feet, but I have plenty of Hewlett Packard feet, so I added the HP feet at the bottom. Okay, it did have the tilt stand, but not the feet. On the rear panel, there is nothing but the serial number tag. Serial prefix 0220A means it was made in the USA and began manufacturing this instrument in 1962. Now I know this unit is newer than 1962 because the color is this olive gray color. I don't know how well it shows up on the camera. This olive gray color. Um, Back in the early 60s, instruments were, let me see if I can find, yeah, here we go. The instruments were um, this blue gray color. Around 1970 or so, they switched to the olive green color scheme, the olive gray color scheme. I think it's called olive gray, and the lighter color is called mint gray or something like that. I believe it was probably so they could sell more of these units to the military, but I don't really know why. But they did change from this bluish color to this greenish color around 1970 for the most part. So this probably is newer than 1970. I don't know if we'll be able to find a date code, on the inside. Now, I have done some preliminary testing on this attenuator, and I found that basically it works. Nothing really could go wrong with it unless you fried it with some high voltage or something. Basically, it works, but the readings are a little unstable, and that means the switch contacts are dirty and they will have to be cleaned. So we're going to have to open it up and maybe deox it or something like that. So let's do that now. Okay, so we just use a posi drive screwdriver to remove the posi drive screws, and there's only one screw in the back here, and the top cover should come right off. Hopefully, anyway. All right, so there we see inside we have metal shielding cans around both the 10 dB per step attenuator and the 1 dB per step attenuator. We're going to have to try to figure out how to get these cans off of there in order to get inside and clean the switch contacts. Um, Not much else to see, really. But let's take the bottom cover off and the side covers off too, so we can get at those cans a little bit more easily. Okay, so I've removed all four covers, and I want to also remove this top spacer from the instrument so that I can get better access to the attenuator cans inside here. So I'm just going to pull these two screws out, one on this side and one on the other side, and remove this top spacer. There's a nut behind it with a star washer affixed to it, and these just should come right out. There we go. All right. Now, if you take a look at the shielding can around the attenuators, it's held in place with this little C-shaped tubular clip system, and we have to slide this tube off in order to open up the shield. It might be a little bit tricky. Might be the best way is to take it apart more completely, remove the shaft from the front panel, and pull the attenuator switch assembly out in one piece and work on it that way. I have to make a decision about that, so let me stop the camera and take a closer look to see the best way to go about this. All right, it came apart more easily than I thought. This little C-shaped clip with the slot here just slides out and the shield opens up. I think we can work on it simply from here. You can see the precision resistors inside and the rotary switch. Hopefully I can get it back as easily as I got it apart. I'm not sure about that. Sometimes that's the tricky part. But at least I will have access to the switch contacts to be able to get them cleaned and back to functioning 100%. So let's do that now. Okay, so I wanted to take a second to talk about some of the various chemical products I use to clean switch contacts and the advantages and disadvantages of each, and what's the best time to, which is the best product to use in each situation. Okay, so first we have this Tarnex tarnish remover. If the switch contacts are silver plated and they show that they have a lot of corrosion, I will use the Tarnex tarnish remover. This product is very strong and powerful, so you have to use it very sparingly. Just apply a small amount on a cotton swab, Q-tip, or sometimes I use these foam tipped swabs to carefully wipe the surface of the silver plated contact to remove any tarnish using a tiny amount of the Tarnex tarnish remover, just a very tiny amount. Now, in addition to that, after you've done that and removed all the tarnish, you have to go back and rinse the contact with some distilled water or deionized water on a separate clean Q-tip or other swab to remove any of the Tarnex residue. That's the one disadvantage of Tarnex, is it's an acid, and if you leave it on the switch contact, it may look like you have removed the tarnish, but in fact, you will eat up your contacts, and it will be much, much worse within a matter of months. So if you use this product, it has to be rinsed off. So do that very carefully. So I try to avoid using this unless it's really a severe silver-plated tarnish switch contact. So that's the Tarnex. Of course, we have deoxit. Deoxit D5 is used for switches like this. Um, I like this product. It's a really very good product. And what I don't like about it is that it leaves a lubricating residue, sort of an oily type of residue to lubricate your switch. Um, Oftentimes, that lubricating residue can attract dust, which in turn absorbs moisture and becomes conductive and will cause a problem with uh, the situation that you try to resolve to get even worse. But I still like to use this product, but I do it instead of spraying using the little nozzle to spray it where it ends up getting everywhere. You don't really want to do that with this product. If I, again, spray the tiniest amount on the end of your Q-tip or your foam swab, and then get in there and clean the switch contact with the deoxit. The deoxit is a very good product to use that way. I don't recommend that you spray it in there like with the nozzle and the little straw sprayer. Um, the lubricating residue gets everywhere, and it's more difficult to remove. If you do get that residue everywhere, the way to remove it, best the best way to remove it is using this isopropyl alcohol. I mean, it's basically, this is your universal solvent. You want to use this for almost all your cleaning, um, exterior and interior on your instrument. Um, the one I prefer to use is this CRC QD electronic cleaner. I use this one, and I can spray this one right in there if I want to, without worrying about it leaving a residue. This this product evaporates completely and doesn't leave the lubricating residue like the deoxit will leave. It means, of course, that it doesn't lubricate your switch at all. So if you need to lubricate it, I would go with the deoxit and use a Q-tip. This one, you can use a Q-tip on this too, but it evaporates very quickly. It's just easiest to spray it in there and work the switch back and forth several times. Um, I, I prefer this product. It's the easiest to use and it works quite well. So this is the one I would recommend. Now, I'm not being sponsored by any of these products, of course. These are just my personal recommendations and what I like to use. On this one, I think I am going to do the deoxit with the Q-tip and get in there and carefully clean it. I didn't see a lot of silver tarnish, at least on the 1 dB per step attenuator section. I didn't see a lot of silver tarnish in there. Um, so probably the deoxit on the Q-tip will work the best in this particular situation. So that's what I'm going to do with this one. Okay, so after cleaning the switch contacts, I close the can around that switch and slide this C-shaped clip back onto the can to seal up that attenuator, and it should be good as new. I'm going to repeat the same process with the 10 dB step attenuator, and I'll be back when that is completed. All right, so I quickly realized that when trying to slide the C-shaped rod clip thing off of the 10 dB per step attenuator, it's much longer and it actually bumps into the rear panel and I can't get the clip off. So I will have to remove the rear panel from the instrument so I can get the clip off and then open up the can for the 10 dB per step attenuator. So that's what I'm going to do now. And with the rear panel removed, I can slide this out and the 10 dB step can opens right up, revealing those precision resistors and those switch contacts. So I'll repeat the same procedure and clean the switch contacts on this section as well. Okay, with those switch contacts cleaned, I will slide the C-shaped clip, hopefully. And no, I didn't get it. There it goes. back onto the can. I was holding through these little holes. I was using my needle nose pliers to hold it closed until I could get the clip started, and then it slides back into place. All right, let's reassemble the entire unit and do some testing. Let's see if it worked. All right, so I reassembled the entire unit and I'm ready to test it. So let's take a look at the test setup. We have my 204C oscillator, which has a 600 ohm output impedance. I mean, might as well test a 600 ohm attenuator with a 600 ohm output oscillator or signal source, right? So I have my 204C set to 1 kilohertz. Its output is adjusted, its amplitude is adjusted over here. 600 ohm output goes into the input of the attenuator. Output of the attenuator goes into my homemade 600 ohm banana plug dummy load. This is a pair of 1.2K precision resistors in parallel, connected into my Panoma. I don't know the model number, but it's a dual banana plug. So that's my 600 ohm dummy load or termination, okay, into a banana to BNC adapter into my 400E AC voltmeter. 400E is set to 1 volt. I've adjusted the amplitude for 0 dBm, 0 dBm at 600 ohms, which is 1 milliwatt at 600 ohms is 0.775 volts actually. And so that's what we have with our attenuator set to 0 dB. When I step through from 0 to 10 on the 1 scale, 1 dB per step scale, let's see what the meter does. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. All of those work perfectly. Now we can step through the 10 dB per step, and while doing that, we can decrease the range on our voltmeter to keep the meter reading at 0 dB. So we'll give 10 dB of attenuation, drop down by 10 dB on the voltmeter, still read 0, 20 dB, 30 dB, 40 dB, 50 dB, 60 dB. Now below 60 dB, we can read down 10 more dB on the meter, down to 70, and that works just fine. I can't measure the rest of the readings with my current setup. I can measure it using a spectrum analyzer or some more sensitive test equipment than this. But we can see that so far the 1 dB per step attenuator section works perfectly, and the 10 dB per section works perfectly from 0 down to 70 dB of attenuation. I can't test these last 3 steps, but I can probably assume that they're working fine as well. I wanted to do another test where we can hook it up to my spectrum analyzer with the tracking oscillator, so we can sweep through from 10 hertz up to as high as we want to go and see what the frequency response of this attenuator looks like. So let me get that thing set up, and we'll come back when that's ready to go. Okay, so we've set the output of the tracking generator into the input of our 350D attenuator. The output of the attenuator goes into my 600 ohm load into the 1 meg ohm input of the 3585A spectrum analyzer. The output of the tracking generator is dialed up all the way. My attenuator is set to set to 10 dB of attenuation. So we're looking at the 10 dB step attenuation, and we're going to look at the frequency response. I've set my sweep from 0 hertz to 5 megahertz in frequency. Vertical resolution is set to 1 dB per division in vertical sensitivity. And we've set our 0 offset reference at our 0 dB point. So now I'm going to dial up the marker until I hit the 3 dB point and read that frequency. Here's the 3 dB point right here, right about here, exactly right about there. And that frequency is 2.73 megahertz. So the bandwidth, at least of the 10 dB step attenuator on this 350D attenuator, is 2.7 megahertz. Not really just 1 megahertz. It actually goes up to 2.7 at the 3 dB point. So it's a very good attenuator, I would say, even though it's a 600 ohm output and input impedance attenuator. It's which is mainly used for audio frequency. It actually goes up to way past 1 megahertz in its frequency response. So, oh, by the way, I did get a date code off of one of the components on the interior of the instrument, and that date code indicates that this instrument was actually made in 1977. So that's how old this instrument is. It was made in 1977. That was the year I was in 11th grade in high school in 1977. So that's when this was made. So there you have it, the Hewlett-Packard 350D attenuator set. I think I will actually use this instrument in my lab. Thank you very much for watching. Please like and subscribe, and stay tuned for more fun videos with vintage test equipment. Thanks again.